All right, everyone. Welcome, everyone. Thank you for joining the summit today. Today, we'll be covering how to maximize your database price performance using Aurora and the Graviton2 instances built by the AWS Graviton2 processors. My name is Nitesh. I'm a product manager for Amazon Aurora. And with that said, let's jump right into the agenda for today. So today we'll be covering three things. First, discussing about Amazon Aurora, the service, why we decided to build it, and what our customers love most about it. Then we will cover the AWS Graviton2 processors, specifically why we built the Graviton2 processors, some of the benefits that the Graviton2 processors provide versus the Generation 1 Graviton processors. And finally, we'll discuss about how you can maximize price performance for your databases using both Aurora and the Graviton2 processors. So let's discuss a little bit about why we decided to build Amazon Aurora. So Amazon Aurora provides commercial-grade cloud-native databases. And what that means is we provide Amazon Aurora as a fully managed service, which provides the same capabilities as a commercial-grade database, which means high availability, high performance, high throughput, low latency, delivered at 1/10 the price. There are no licensing fees. You only pay exactly for what you use. And it's available in two different open source flavors, specifically MySQL and PostgreSQL. And it's open source compatible with drop-in compatibility with both these databases. And what that means is if you're using a MySQL or a PostgreSQL database today on your on-premise deployment, EC2, or a different cloud provider, you can easily use Amazon Aurora with no code changes. We also provide multiple value-add features, such as global database and cross-region disaster recovery. So enterprises who have DR needs can rely on these features, and a lot of our customers continue to love those features for that reason. And lastly, it's pay-as-you-go pricing, which means there's nothing to pay up front. You only pay exactly for the hours, the IOs, and the GBs that you use at a daily basis, with other payment plans available to customers who need them. So what is the main value proposition of Amazon Aurora? Well, first, it's a fully managed offering, which means that developers or DBAs or DevOps personnel do not have to do any undifferentiated heavy lifting. They can easily launch databases whenever they need it. They don't have to patch, upgrade, or deprecate any of the versions. They don't have to worry about taking upstream features from the community, install any special extensions. All of that is taken care for you. You can use the CLI, the AWS CLI, the API, and the console to kind of provision these databases when you need it and tear them down. And of course, it's 1/10 the price of similar commercial databases. Especially, Amazon Aurora provides auto-scaling storage. What that means is we have separated out the storage layer and the compute layer, and we will talk about that a bit more. But Amazon Aurora goes all the way up to 128 terabytes. And especially, you don't have to provision any storage upfront either, because you're only paying for exactly the storage that you use. And then if you don't use any of the storage, for example, you went high and then you went low on your storage, we'll only charge you for exactly what you used. So let's discuss the primary innovation behind Amazon Aurora, and that's the decoupling of the compute layer and the storage layer. And what this allows us to do is, based on your workload or your query traffic, we can add more compute in the storage side to process query faster. We can scale the storage. And more importantly, the storage is very highly durable. That's really important for a lot of our customers who need high resiliency, and they need 99.9% actually, SLA for their applications, especially tier 1 applications, production applications. So here I'm sharing on my screen what that looks like. So as you can see, we support up to 15 read replicas and one primary instance. And at the storage nodes, we split the data, or we replicate the data across 3 different availability zones within a region. So if something happens to one of those availability zones, we still have 2 more availability zones to continue serving your application traffic. Amazon Aurora uses a 4 out of 6 quorum to do this. So your data is always available, it's correct, and you can continue serving your application even in case of failures or any disaster situations. This is the key thing, the key value proposition that our customers really love about Aurora, which is the performance and the resiliency that we're able to achieve by decoupling the storage and the query processing. Now let's switching the kind of our forum a little bit. We're talking about Graviton2 processors next. So AWS offers the broadest choice of processors today in the market. We currently offer Intel and AMD processors. So right now, the Intel Xeon processor family, the AMD EPYC processor family, and with Graviton, AWS has launched its own line of processors. So before we discuss Graviton specifically, I wanted to discuss why we decided to do this. So the AWS Graviton2 processors are built by Annapurna Labs. They're using the 64-bit ARM Neoverse N1 cores. And the reason we wanted to do it is we have tons of experience in the cloud industry. We have been working with a lot of our customers, and they wanted us to kind of own the whole stack, not just the infrastructure, the software, but also the processors itself. We decided to build the Graviton2 processor because it's built specifically for cloud-native workloads. These customers might want better performance, high throughput, easier scaling, and the Graviton2 processors are built with that in mind. We started off with the Graviton1 processors, of course, a few years ago, and since then we have continued to make improvements and worked our way towards Graviton2. So how are the Graviton2 processors built? Well, we decided to split out the vCPUs. So that means each single vCPU sort of uses its own memory and has its own scheduler resources rather than using one combined processor queue, similar to how Intel or some of the other processors in the market do it. And what this means is for CPU-bound workload, you get much better performance because now your processes or your workload are being split across those independent processor sockets. We also give you better uniform memory access because of how the chip is built, which again reduces the latency. We've also made improvements in terms of the security. And we also have given customers higher EBS throughput when they use Graviton2 processors. And what this means is Graviton2 compared to Graviton1 now provides 7x higher performance. It provides 4 times the compute cores, 5x faster memory, and 2x cache of Graviton1 processors. Like I said earlier, it's built on 7-nanometer technology, the chip itself, and it's built using 64-bit ARM Neoverse cores. And here I'm sharing an actual photo of the Graviton2 processors that are in our servers that are built to serve your workloads. We have given customers a lot of choices as far as instances are concerned. There are the EMS general purpose M6G, R6G, C6G. We also launched the T4 series, T4G series, and I continue to make innovations in the form of the X series, the X2G series as we call it. And a lot of customers have given great feedback regarding these instances. So now let's put together the innovation that Amazon Aurora provides, specifically delivered as a fully managed service and Graviton2 processors. So the primary benefit of Graviton2 and Amazon Aurora is that you do not have to worry about performing any undifferentiated heavy lifting. We have provided Graviton2 instances for you. So it's a simple instance change operation. And when you do that, when you change your instance from an Intel to a Graviton2 processor on Amazon Aurora, you're instantly getting 20% performance improvement and 35% price performance improvement. I do want to highlight the fact that it's 35% price performance. So when we say price performance, what we're really saying is Graviton2 processors are priced, or instances on Aurora are priced roughly 10% lower than existing comparable Intel instances. And additionally, they provide 20% better performance. So this nets out to a 35% price performance for your workload. And the actual performance that customers will get really depends on how they're using the Graviton2 processors, what their workload characteristics look like, whether the workload is CPU bound. And then we, of course, ask customers to run their own workloads through it. So I want to summarize a little bit more about what customers can expect when they use Graviton2 instances. So like I mentioned, the main value proposition of using Amazon Aurora and Graviton2 is that you get up to 35% better price performance on Aurora. That's massive. So if you have an Intel instance today, by simply changing that workload by a very simple CLI call or a console call, you immediately are getting up to 35% better price performance. That can yield a lot of cost savings for some of our more cost-conscious customers. And we are seeing a lot of customers adopt Graviton2 instances on Aurora for that particular reason. It's an easy upgrade. It's fully compatible with all Amazon RDS and Amazon Aurora features. There are some features that might not work, but we're continuing to close the gap in terms of the feature parity work. But by the time you look at this presentation, we'll have bridged most of those gaps, and we continue to close those gaps as soon as possible. We also don't require customers to do any porting, and what that means is if you have applications that are using Graviton2 processors, you might have to worry about porting the binary for the ARM, but you don't have to do that on a fully managed database like Amazon Aurora. All that work, the testing, the performance tuning, the benchmarking, and making sure that the Graviton2 processors and databases on those processors are working perfectly, we have done all that work for you. Like I mentioned, Graviton2 processors themselves provide higher Amazon EBS and network bandwidth. So that means that your network-bound traffic is being processed faster, which again, for some of our performance-minded customers is really important for some of the high resiliency, high performance applications. On Aurora specifically, as I had mentioned earlier, you can create up to 15 read replicas within a cluster, as we call it. So you have one primary node and 15 read replica nodes or readers that serve read traffic. With Graviton2 instances, you can mix and match Intel and Graviton2 instances within the same cluster. So if you have an Intel instance that's the primary, you can have 15 or maybe half of the readers be Graviton2, the other half can be Intel, and then you can kind of split the traffic based on however you need it if you want to mix and match instances. So that's, again, flexibility that you get on a fully managed database service like Amazon Aurora. And like I mentioned, now the Graviton2 instances are available for Amazon Aurora MySQL, PostgreSQL, and we have also supported these instances on our RDS offerings, which are the RDS PostgreSQL, the RDS MySQL, and the RDS MariaDB products as well. So with this launch, we have complete support on all our open source database offerings. So let me cover real quick what the performance benefits are. I know a lot of our customers are really curious, hey, what sort of performance can I expect? How should I kind of do the benchmarking? And what we usually tell customers is that you should always do your own benchmark using real-world applications, preferably production workloads if you can, to really hone down on what sort of benefits you can expect. But to give customers some confidence that the Graviton2 processors do provide higher performance, we have run our own benchmarks. Specifically, we rely on HammerDB, which uses a TPCC-like benchmark to benchmark Amazon Aurora, the Graviton2 and Intel instances. We also use Sysbench and PGBench, which are, again, more database performance testing tools to really hone on what customers can expect if they're using similar workloads, like an e-commerce workload processing traffic, a retail workload, and what sort of improvements you can get with Graviton2 processors. So here I'm showing you using an R6G large and comparing that with an Intel R5 large on Aurora. We ran a benchmark using HammerDB. We used roughly 16 warehouses. And you can see that as traffic scales on the higher end, Graviton is more than 1.15 times faster than a comparable sized R5 instances. This is again due to the separation of those vCPUs, like I mentioned, having their own single thread for their own CPUs that gives you that benefits. And yeah, as you go larger and larger and put more traffic on your database, you can see Graviton2 really starts to yield some of those performance benefits. And here we are showing you a simple running a 1,000-row sort of a range scan using Graviton2 instances. This is on the higher end. So we have compared R5 24x large, which is the largest size offered today, one of the largest size offered today with the existing Intel instances, and an R6G 16 large, which is the largest size offered in Graviton today. And you can see that an R6G large actually outperforms an R5 24x large. So you can see that there is clear cost savings because now customers can potentially, depending on their workload, downsize from a 24x large Intel instance to an R6G 16x large instance, which again gives more performance savings besides just the price performance that we covered earlier. So truly, Amazon Aurora and Graviton2 deliver highly on the price performance and the cost savings by combining both the best of both worlds, delivered again in a fully managed fashion. So that covers some of the benefits of Graviton2, and I want to leave you here with some of the resources that you can use to read up on Graviton2 instances, learn how to migrate to Graviton2. Here are some links that I've pasted here. So the first one is a blog on some of the considerations that customers have to kind of worry about or think about before moving to Graviton2. As far as we know, from all the feedback that we have gotten from our customers, there is no reason why a customer would not migrate from an Intel instance to a Graviton2. We have heard great feedback from all customers who are moving to Graviton, and we are pretty confident about the price performance benefits that customers can get. I've listed out the pricing. So the pricing page is public. We offer the same pricing options and payment plans as our existing instances. So that means using the 1-year reserved instance, the 3-year reserved instances, all those are offered to our customers as well. And finally, we have listed out the different instance families that we continue to add to Graviton2. And you can look at the last link to kind of get some of the technical details, such as how many cores, what sort of memory, EBS bandwidth that you can get using Graviton2 instances that are available in Aurora today. So that pretty much wraps up a summary of Graviton2 and Aurora. We discussed why we built Amazon Aurora. We discussed the Graviton2 processors themselves. And we finally wrapped up by combining both Aurora and Graviton2 instances delivered again as a fully managed service. And here are some links that you can continue to learn more about databases using training and certification. We have up to 45 free digital courses. We have deeper in-class training. You can also get certificates if you are interested in that by using the certified databases specialty. And then we have also posted a lot of labs, white papers, and tech talks on the AWS Ramp-Up Guide. I think the shortest link is aws.training/databases, which will give you all those resources that we just discussed. And with that said, thank you for your time, and thank you for joining the AWS Summit today to discuss Aurora and Graviton2. Again, my name is Nitesh Mehta, and it was a pleasure talking to everyone here. And you can reach me at my email that I've pasted on the slide. Thank you very much.